In this video, we're going to be taking a look at the chain rule. So yesterday we talked about power rule, which is a way of taking a derivative of a polynomial function in standard form. Today we're going to look at what happens if our polynomial is in a bracket with an exponent. What would we do? So we're going to start with a little investigation. It says expand each of the following to determine the derivative using the power rule. State your final answer in factored form. So I'm looking at a of x, which is 3x to the 5 plus 7 all squared. Now that I cannot currently take the derivative of with the power rule because it has a bracket, and the power rule doesn't work when we have brackets. So what I'm going to do is follow the instructions. We are going to expand or multiply that out, collect up our like terms, and then see if we can take the derivative using power rule. So 3x to the 5 plus 7 squared really means 3x to the 5 plus 7 times 3x to the 5 plus 7. And then we are just going to multiply that out using our distribution skills. So 3x to the 5 times 3x to the 5 is 9x to the power of 5 plus 5, which is 10. 3x to the power of 5 times 7 is 21x to the power of 5. 7 times 3x to the 5 is also 21x to the 5. And then 7 times 7 is 49. All right, I do see that we have some like terms in the middle, so I am just going to collect those. So a of x in its expanded form is 9x to the 10 plus 42x to the 5 plus 49. So now that we've expanded it out, we should be able to take the derivative using power rule. Yesterday, when we talked about power rule, we said that you would take the exponent times the coefficient, and then we would take one away from that exponent. So if I go to do the derivative of a of x, we're going to write that as a prime of x. I would start with 9x to the 10, so 10 times 9 is 90. And then x to the, and I take 1 off the exponent, so 10 take away 1 is 9. So I would get 90x to the 9. 42x to the 5, I'm going to multiply 5 and 42. That should give me 210. And then I take 1 off the exponent, so x to the 4. The derivative of 49 is just a constant. It does not have an x, so it would just be 0. But if you need to, you can put in its x term, which would be x to the 0. And then 0 times 49 is 0. And then it doesn't matter what happens with x because 0 times anything is just 0. So our derivative is 90x to the 9 plus 210 x to the 4. Now, the original question was written in a bracket, so I would like to try to write this answer in a bracket, meaning we are going to factor it to see what it looks like. 90 and 210 both end in a 0, so that tells me they divide by 10, and 9 and 21 both divide by 3. So I'm going to say that I think I can factor out a 30. They also both have an x. Lowest exponent is a 4. So we're going to factor out a 30x to the 4. And then I'm going to ask myself, what would I multiply 30x to the 4 by to get 90x to the 9? Well, I would need to multiply by 3, and then I need 5 more x's, so x to the 5. How do I turn a 30x to the 4 into a 210x to the 4? Well, I would just need to multiply that by 7. Okay, now I am going to do one more step to help us with the investigation part of this. So this is how I would normally write the answer for the derivative. But I am going to go one step further just to help you out. And I'm going to say that a prime of x, I'm going to break up this 30x to the 4 a little bit just to kind of help us find a pattern so that we can figure out the rule here. I'm going to say that 30x to the 4 is 15x to the 4 times 2. Why did I break it up like that? Because I know what I'm doing. I know what the rule is that we're trying to find here, and I think that that's going to help us. Right? So normally I would stop at that last line. This is just to help us figure out the rule for chain rule. There is a second example that I've already worked out. It was 5x minus 1 to the power of 3. So I multiplied all of that out for you. I used Pascal's triangle to do it. And then I took the derivative, right? I factored out a 15, and then I factored the bracket to get 5x minus 1 squared. I'm also going to add one extra step here to kind of help us find the pattern. I'm going to break up that 15 and say that is 5 times 3. I almost wrote a 2. It is 5 times 3 times 5x minus 1 squared. Okay, so what I'm going to ask you to do, there is a little instruction down here. It says think, look for a pattern, and predict the derivative of c of x, which is 9x squared plus 5 to the 10. So what I'm going to ask you to do is, once this video is done, I would like you to look at the original function a of x and look at the derivative after I did that weird step where I broke up the first number. Look at b of x and look at that step that I added at the end. Do you see a connection? Right? Is there a way for us to get from here to here, right, without having to multiply it all out? That's what we're looking for. And then use that to see if you can predict what c of x is going to be. And in the next video, we will take a look at my answer, right? And then we'll talk about what the chain rule is. But I'd like you to try to see if you can figure that out yourself.